Great. I think most people have now seen that video clip enough times that I don't have to introduce my topic. But I want to talk about Angular a bit more. How many people actually here are Angular users or use Angular? Okay, most people. That's great because this talk is really catered towards Angular users. Though it hopefully will be interesting to everyone else as well. So I want to focus on one specific area of Angular, which is the directive system. And that is mostly because it's really the distinguishing feature of Angular. Most other frameworks don't have anything exactly equivalent to that, this ability to create new HTML elements and attributes and build your application from those. So you can do things like this with Angular. You can use HTML elements and attributes that don't actually exist in HTML because you can write those using directives in JavaScript. Though of course we now have the web component standard which does something similar to this, and Angular 2 actually uses that standard, but Angular 1, which is what I'm going to talk about, does not use it. It's only conceptually similar, not implementation-wise. So it's a very useful feature, but there are also problems with it. Mainly that it's quite difficult to learn, and that has a lot to do with the API of the directive compiler. So in Angular 1, when you want to make a directive, you have these 15 or so different configuration options that you can tweak, and those have a lot of interdependencies between them. So when you change one, how another one behaves changes. And this is a stumbling block for many people, has been to me at least, how to actually figure out how to use all of this. And it's a problem because when you're using some API, you want to feel like you're in control. You want to feel like you understand all of it, that you're using it effectively, and that you're not doing anything in a more complicated way that's necessary. And so what I often do when facing a problem like this is I go to the source code, because if the documentation isn't good enough, if the API isn't simple enough, I go to the source code. That's the beauty of open source. You can actually go in and see what's going on in there. But there's another problem with that in Angular, which is that the source code is also kind of complex. So the compiler is in this one file in the Angular code base, which has over 1,300 lines of pretty dense JavaScript code in almost 100, sometimes deeply nested functions. And it's not just the compiler that's in there. There's a lot of features in that file, including attributes, controller stuff, a lot of it is there, isolate bindings, templates, transclusion. Many features interleaved in the single file. So if you're trying to learn some feature, it's hard to, well, first find it from this file, and it's not going to be in one place in that file. So that makes it more difficult to figure out. So the strategy I have adopted is to flip this around a little bit and to learn this stuff not by reading the source code, but by actually writing the source code. And that's a sort of a process of learning by imitation, which is what children do, both human and animal children, which is to see what someone else is doing and try to do the same after them. So what I'm trying to do is essentially build up the Angular framework, or the core parts of it, from scratch, and in the process learn why it's built like it is, what all the features are, and how they work together. And that's what I've been doing for the past over a year now with my book project. And today I'm going to share a little bit of that process by showing a few things about the directive system. So as I said, there's a lot of stuff in that directive system, but I think there's this smaller core that we can also concentrate on, which we can kind of do in a session like this. Doing it all would probably take a week, but we can find this simpler core and do that. And that consists of 4 parts. One is the compilation process that Angular does when it starts, the DOM compilation. The other is the linking between DOM and scopes. Third one is how scope inheritance happens in this process. And the fourth one is how isolated scopes get created and managed during this process. So that's our roadmap for today. And let's get right into it and talk about the first of these steps, which is the compilation. So we, of course, should define this term first, because compilation can mean so many different things. What we mean by compilation in Angular is this process or this function that we have that has certain inputs and outputs. The inputs for this process are a collection of directives that you have registered to your application and a piece of DOM that you want to apply those directives to. And the compiler essentially combines those two together to produce this compiled DOM. It applies those directives to the DOM. So in code it looks something like this. You have this compile provider to which you can register directives, and they have names such as my class here and factory functions, and those factory functions then return the actual directive objects, which are those things that we looked at earlier. This directive object is a simple one. It just has a simple method called compile, which does something to the element. In this case, just adds a CSS class to it, but it could really do anything to the element, transform it somehow, decorate it, add behavior. But that's the simplest kind of directive you can have. And then you have some DOM on your page, some HTML, which kind of matches by attributes or something those directives that you have. And what you do, or what gets done for you, is that element gets grabbed from the page, wrapped inside an Angular element, and then fed into this compile function, and with the expectation that it will now apply those directives that have been registered to the element. So let's switch perspectives then and see how to actually make this happen. We're going to need this compile provider into which you can register directives. So we make a constructor for it, and it has this directive method that takes directive names and factory functions as arguments. That's how you register a directive. What that method does, it has this internal storage in this provider and just puts every registration in there. So the keys in this storage will be directive names, and values will be the directive objects, which we get by calling that factory. And one thing that's going on here is that in Angular you can have several directives with the same name. So we have to support that, so the values in this object are actually arrays, which can be like several directives for a given name. And when we have that, we can then proceed to make our compile service. So this is a standard Angular provider that has this $get method that actually makes the thing that you want, and there's the compile function that you actually get when you inject it into your Angular application. It's this function made by this provider that takes an element, and that function should now compile that element. So what does that actually mean? Well, first of all, the compile service itself, or the function, doesn't do very much except just delegate all the work to another helper function we're going to make inside this get method called compile node. And the job of that function is to compile this single node. And that has a couple of steps to it. The first one of those is to actually find all the directives that should be matched to this element. And for that, we're introducing another helper function called collect directives. And that we expect to find any directives that match to this element and return an array of them to the caller, so we can then apply them later. And you can match these directives in three different ways. You can match directives to elements by looking at the element's tag name. You can do it by looking at the element's attribute names, or you can do it by looking at the element's CSS class names. And what we do is we try all of those strategies and return a combined collection of all the directives that we have found by any of them. So let's look at how that matching actually happens inside these functions. So first we're looking at how to match directives to an element by the element's tag name. We have to get that tag name first, which we get by the standard DOM node name attribute from the element, and that's going to be an uppercase hyphenated string, whereas our directives are actually camel cased, or have names that are camel cased. So we need to use low dash or some helper function to camel case that string. And then we can just look it up from the directive storage. We find any directives that have been registered using that method that we introduced earlier with this name that matches the camel cased element name, and we just return that array from this function. Or we return an empty array if we don't find any of those directives. For attributes, we do a similar trick, except that we just have to have a loop here because an element may have several attributes on it. So we iterate over them. For each attribute name, we camel case it and then find the corresponding directives from our storage and combine all of those into this single result array and return it. So we go over each attribute, find the directives that match, and return everything we find. And thirdly, for CSS classes, we do the same thing essentially. We get the DOM class list of that element, which gives us a collection of all the CSS class names that are present on that element. Camel case each one, find from the directive storage the directives with that name, and return a combined result. And once we're done with all of that, we have this one big array of directives that match with any of these three strategies. And then what's left to do is to actually apply those directives to the element. And that happens back in compile node, where we now have this directives array. So we simply make a loop over that array, and for each directive that we have, we call the compile method. And that's where the directives compilation actually happens. That's where our example directive adds that CSS class that it did to the element. And that's where directives actually do whatever they have to do. And there we have actually now compiled that node. But before we're done with the compilation in general, there's one more thing that we should do, which is that when you give an element to the compile service in Angular, you don't expect it to just compile that single element, but instead you expect it to compile the whole DOM tree that starts from that element. So we have to look at the child nodes of this node as well and compile everything we find. That's actually quite simple to do now. We can just get the children of this element using the Angular element API and recursively invoke compile node for each of those children. So we have this recursive invocation of compile node where, again, for each child we find the directives and apply them. And we end up with this essentially depth-first tree traversal of the DOM tree, where for each node we go over, we find directives, apply them, and when we are done with the tree, we have compiled our DOM. And there is a simplified version of everything that happens when Angular compiles a DOM. It just finds directives, applies them, does it recursively for the whole tree that you give it. And that brings us to the next topic, which is linking. So what we have so far is essentially, it's kind of useful by itself, but it's more or less just a kind of replacement for jQuery, where we have these matchers and some JavaScript code that we run when we match things. But where we start to bring in the rest of the Angular framework more into the picture is when we start to talk about linking. Because linking brings in scope objects. And if you are an Angular user, you know how important they are. They are where you put your application data and functions, so you can share them between templates and controllers and directives. And scopes are the host of the Angular change detection system, because that's where you watch things, that's where you digest and apply. And scopes are actually also the host of the Angular event system, because that's where you emit and broadcast and listen to events. So they're a really central piece of the Angular architecture, at least Angular 1 architecture. So, and the process of bringing in scopes to directives is called linking. So we need to expand our sort of diagram of what the compiler actually is a little bit. So we now have these two processes going on here. The compilation process is the one we already saw, which takes these directives and DOM and combines them. But we have this other process now called the linker, which is another one of these things that has inputs and outputs. So the inputs to this thing are the compiled DOM from the previous step and the scope object. And it applies those two together to produce this sort of linked DOM. And what's further interesting with this is that there is no link service in Angular that you could inject, such as there is a compile service. Instead, this linker is sort of an output of the compiler. You get it from the first step, which is a bit weird, but we'll see how that works. So to look at the same thing in code, you can now have directives that have a link function in them. And here we have one that takes two arguments now, the scope and the element. And it can do whatever it needs to combine those two. So this is a directive that still just adds a simple CSS class to an element, but now the class name is actually dynamically defined by the scope. It's kind of an input to the directive. And that's kind of a simple thing that a link function can do. And the most low-level way you can define a link function for a directive is to return it from the compile function. You'll probably know that there are other ways of doing the same, but this is what they are all essentially built on, this fact that the compile function returns a link function. And how that looks like from the other side when you actually use the compiler. When you call the compile service, you have to grab the return value that you get from it, because that's going to be the link function for that compilation. And then you can later call that link function, giving it a scope as an argument. In this case, we added the root scope, but it can be any scope. And that's how you initiate the linking process, by calling that link function that you got from the compile function. And that's how those two things connect. So moving back to our implementation, what we now expect compile to do is to return something, which is the link function. So first we need this return statement in the actual compile service. And all the work is again done by this compile node function, where we now actually construct this node link function that gets called for this particular node. And that's the function that we just called from the other example that is given the scope object. And the job of this function is to link the node. So what does that actually mean? It really doesn't mean anything else than calling all the link functions of all the directives that were found for this element. So what we need to do is, during compilation, we need to introduce this new array into which we're starting to collect all the link functions that we get. And we get them from those directives when we call their compile functions. So for each compile directive, we get a link function. We store it in this array. And then later, as we get to the linking phase, we have that array which we can just iterate over for each link function. We just call it with the scope and the element. And that's where the directives link functions get called. So between the compilation and the linking, the directive link functions are sort of sitting there in this function closure, which is a sort of interesting way to hide that state. So you don't actually provide the link functions or the DOM elements or anything when you call the link function. It's kind of internalized by this closure that you can call. But there's one more piece to linking, which is again to handle the child nodes, because we need to link those as well. So if we look at how we compiled the child nodes, we have this recursive invocation of compile node there. And if we look at what compile node looks like, it now returns a node link function. So to be able to link the child nodes, we need to grab the return values of the recursive invocations of compile node, which we can do with the map function, because that gives us an array of the node link functions of the child nodes. And then we can loop over that as well as we go to the linking phase. We have another array which we loop and call each one. And that's essentially just the node link function recursively calling itself, which gets done in a little bit of a roundabout, strange way, but it's still just essentially that. And if you notice, we actually link the child nodes or the child link functions before we call the link functions for the element itself, which is a bit peculiar, but it's just because what we have here are so-called post link functions. And that's just defined as link functions that are called after child nodes have been linked. And that's why they are in this order. There are also so-called pre-link functions that are called before we recur to the child nodes. But we're not going to cover those today. It's just another loop here, essentially. Post-link is the default, and that's what we have here. And that's linking. Though it's a version of linking that's missing one crucial piece, and it's a simplistic version, and that's because you may have noticed we give the link function a scope object, and then it just uses that same scope object for absolutely everything, for all the directives in the whole application. And if you are an Angular user, you know that that's not actually what you have in your Angular application. Instead, you have this whole hierarchy, this whole tree of nodes that starts from the root scope and has any number of children that come and go during the lifetime of the app. And there's this whole descendant tree. And furthermore, how that usually looks like is you have this HTML hierarchy in the DOM and a scope hierarchy that have similar shapes. And that's because there are directives such as ng controller that are used in your templates that cause new scopes to be created. And that's how you end up with these sort of parallel trees that you often usually have in your Angular application. And how that looks like when you use them is you have a directive, and the directive can define the scope attribute with the Boolean value of true. And that means this directive is requesting to have a new scope to be created. And when that happens, the scope that it gets to its link function is going to be an inherited one. So then it can put like attributes on it, like the counter here, and be kind of certain that it's not going to interfere with the parent scope or siblings, because it's now for this element only, and it's no longer the global scope. So how can we actually implement this then? Well, we have to do some more work during the compile node function that we have. What we need to do is check if we see any directives that are asking for a new scope. And we have this variable where we put any of those that we find, new scope dir. So we have this directive loop, and here we check for each directive, does it have a truthy scope attribute? And if it does, we put it in this variable so we can use it later. And we also have this check that we only allow one of these per element. So if there are more than one directive that in a single element that are asking for an inherited scope, we simply just throw an exception during the compilation. And you probably have seen such an exception if you've used directives much. But what we have at the end of the compilation now is this variable where we have a directive that asks for a new scope if there was one on this element. And we can use that information when we get to the linking, to the node link function. Then we just check, is there something in this variable? If there is, we create a new scope by calling the new method on the scope that we were given. That gives us a new child scope for that particular scope. And then we use that scope for everything from that point on. All the directives on this node get that new scope, all the child nodes get that new scope, and that is how you end up with these two hierarchies, because we essentially replace the parent scope for this particular node subtree. And in the end, what you get are those two trees of node trees and scope trees that are similarly shaped because of this effect here. So inheritance is sort of, there isn't that much to it. So it was like 3 lines of code we added there. But where things get a lot more interesting is in the last part of our discussion, which is isolate scopes, because there's a lot more going on with those. So let's get into them and define them first. So an isolate scope in Angular is sort of like an inherited scope, but it's a little bit special. It's normal in the sense that it is very much part of the scope tree. So it has a parent, and it is somewhere in that tree like any other scope in Angular is. And it participates in digests, it propagates events up and down, so it's normal in that sense. But it's only different in the sense that it doesn't share any data with its parent. And that's because we don't set up the prototypical inheritance with those. So if the parent scope has an attribute, the isolate scope child of it won't have it. It will essentially be blank by default, have no data shared from the parent. What you then set up to share something is you have these special isolate bindings that you create, where you say that I want this particular expression's value on the parent scope to be evaluated and bound to this attribute on the isolate scope. And you can essentially one by one choose what gets shared to the isolate scope instead of the normal inheritance, which shares everything. So this gains you a little bit of modularity, essentially, and a little bit more control into what actually gets shared between directives. And here's how you use them. So you have a directive that is asking for an isolate scope. The way that works is it still has this scope attribute on the definition object, but the value of it will be an actual JavaScript object, whereas before it was a Boolean. And that just means, please give me an isolate scope when you link me. That object may be empty, but it also may have contents in it. And if there are contents, those are going to be the specifications for the isolate bindings. And how those work, there is one here, is that the values in that object should match attribute names on the element in which you use the directive. And the keys in that object will become keys in the actual scope that you get to your link function. And the net result is that you have these expressions you define in HTML when you apply a directive whose values are bound to attributes on the isolate scope. And it's essentially a little bit like passing arguments to directives. Just there's a little bit more going on than that, but I find it interesting or useful to think of it like that. So that's the final bit that we're going to implement today. There's a few different parts to it. The first is to actually create that isolate scope. So we need another tracking variable in our compile node function as we do the compilation, which we'll call new iso scope dir, which will track did we see any directives during the compilation that wanted to have an isolate scope. And as we then go over the directives and we find some that want to have a scope, we check if that scope value is actually an object, a proper object, instead of just a Boolean or something. Because in that case, it'll be an isolate scope directive. And we put that in that variable instead of the other, which would be a normal inherited scope directive. And we still only allow one of these for each node, so you can either have an inherited scope directive or an isolate scope directive for each node, but never both, and never two of the same. And now we have this tracking variable, and we can use that when we get to linking. So we again check, was there a directive for this node that wanted to have an isolate scope? If there was, let's make one. So we again call the new method on the current scope. We now pass in the Boolean true, which tells the scope, please also isolate this, so don't set up the prototypical inheritance for this scope. But the difference to what we did before here is that we actually don't overwrite the parent scope with this one. We instead introduce this new variable called iso scope for it. And that's because the isolate scope does not get used for everything. It should actually get used for only one thing, which is the link function that asked for, from the directive that asked for the isolate scope. If there are any other directives on this element, they should know nothing about this isolate scope. It's only for the purposes of that one directive. So as we look at these link functions, we should know which one came from the directive that wanted to have the isolate scope. And for that purpose, we need just a little bit of more bookkeeping during compilation. So as we create the link function, or as we get the link function from the directive, we just put in a reference to the directive it came from. And that's just for our internal bookkeeping, because now when we go back to linking, we can check for each link function that we see, did this link function come from the isolate scope directive? We can compare those two values, because only in that case do we give that link function the isolate scope. Otherwise it gets the surrounding scope. So that is how you essentially isolate a single directive. This whole iso scope thing is used for exactly one directive and not anything else, none of the children, none of the other directives on the element. And there is our isolate scope definition. The second part of this is that it's still completely empty, like there's nothing on the isolate scope. And that can be useful, it often is useful, but we should also support setting up these bindings that we see here. So let's do that. So as we create this isolate scope in the node link function, we should also look at the values in that configuration object that are in there. So we make a loop over the scope definition object, which essentially is this function gets called for each of the binding configurations, so we can set up the corresponding binding. And zooming in on this a little bit, what we're going to do for each of those configurations is first figure out what HTML attribute we should be looking at. So we had the values in this object as these strings that begin with the equal sign and are followed by the attribute name. So what we do here is essentially just drop the equal sign from the beginning and grab the rest of the string, which gives us the attribute name that we should look at. But that's going to be a camel case string, and in the DOM we don't use camel case. We use hyphenated strings, so we have this wonderful low-kebab case method, which we can use to turn one into the other. So that's something that Lodash now ships with, that takes a camel case string and returns a hyphenized kebab cased version of it. And that we can match to the DOM now. We have this element that we are linking, and we can look up this attribute name that we got from the scope config from this element. And that gives us the expression that we should evaluate, because that was given when the directive was applied in the HTML. And our job now is to evaluate this expression on the parent scope, get the result, put it on the isolate scope, and keep doing that when the parent expression value changes over time to keep that in sync. And for that, Angular gives us the exact tool that we need in watch. So we can watch this expression on the parent scope, and then attach the listener function, which gets the new value whenever the parent expression changes, and then we just put that on the isolate scope with the attribute name that was defined in the scope config. And that's how you bind this expression to the isolate scope. It's always populated there with the latest version, because the dirty checking mechanism keeps it in sync. But there's one more thing that we should think about, which is that if you've used these equal sign bindings in isolate scope, you'll know that they're actually so-called two-way bindings, something which, by the way, doesn't exist in Angular 2, but in Angular 1 we still have them. What that means is that not only when the parent expression changes should we bind the value to the isolate scope as we have been doing, but also when the isolate scope's attribute changes, we should propagate that change back up to the parent scope. That's what two-way binding means, and we should do it both ways. We're only currently doing the downwards propagation, not the upwards propagation. So let's conclude by doing that other direction. Before we can go there, we need to refactor things just a little bit in our code. The first thing we'll do is parse this expression string that we have. We have this expression string. We use the Angular parse service, the $parse, which gives us a proper sort of expression function that evaluates this expression. And then we'll make an alternative version of the watch that we have here, which looks like this. This is a special kind of watch in the sense that it doesn't actually have any listener function attached to it. It's just a standalone watch function, and from the point of view of the scope, it's just some arbitrary function that it will call for us in every digest. But that essentially gives us a callback. So we say, please scope, call this function for us whenever there's a digest going on. And inside this function, we're now going to do our own little dirty checking or change detection. And what we do there is we evaluate that expression function that we have on the parent scope, which gives us the value that the parent scope currently has for that expression. And then we look at what we currently have on the isolate scope for that attribute. If those two are different, there has been a change, and we put that value on the isolate scope. So from the parent. So this is essentially completely functionally equivalent to the previous watch version. It's just a little bit more low level because we're doing our own change detection now. But the key is that this now allows us to build up the two-way data binding version of it. And the key to that is to introduce one more tracking variable called parent value. And that variable's job is to always hold the latest value on the parent scope that we have seen. So after every time this watch has been called, at the end of it, parent value will hold what we saw the parent expression's value to have the last time. And when we have that, when we see that the parent and child values are different, we can check, is the new parent expression's value different from what we saw the last time? Because if those two are different, there has been a change in the parent expression value, and we propagate it down to the isolate scope by just putting the attribute there. But if those two are the same, the parent value is now the same as it was the last time, but we still have a difference we have detected between the parent value and the child value. That means that on the isolate scope, the attribute must have changed. And here's where we do our upward propagation. And the key to that is that reason why we actually use the parse service. And that's because the expression function, like all expression functions, or most of them in Angular, have this special method called assign. And this is a method that is an expression that evaluates the expression in a special way, which actually replaces its value. So if you have an expression like foo.x, when you evaluate it, it looks up foo from the scope, looks up x from that, and returns it to you. But if you assign foo.x, it looks up foo from the scope and sets x on it. So it's kind of the special method expressions have. And we call it here to go on the parent scope, which we give it, and replace whatever its value is with the one from the isolate scope up there. And that's how the change gets propagated up from this isolate scope to the parent scope. And then all we need to do is to make sure our tracking variables are aligned for the next call of this watch function, so that our parent value points to the one we just sent to the parent. And we're ready for the next time this watch will be run. And that is how isolate scopes do the two-way data binding in Angular. It's a little bit involved, but I think it's somehow comprehensible. And that's what I wanted to share today. So this compile service is pretty large, but I think there's this smaller core that you can actually look at and understand, and hopefully you now have a little bit of better understanding what exactly happens when Angular starts up and it starts compiling stuff on your DOM, and how the scopes get created and how isolate bindings are created. And yeah, if you want to look at it more, you'll hopefully have some stuff in that file that you'll now recognize. And I'll end with an advertisement. So if you are interested in this kind of stuff, this is essentially what my whole book is about. It's now over 800 pages, which is much more than I ever wanted to write about this, but I have now written it about scopes and directives and dependency injection, promises, HTTP, and expressions, and essentially building it up from scratch in this way, using test-driven development. And in the process, essentially learning how Angular works in a very, very deep level, so that you actually know exactly what it's doing all the time, and you know why it has the features that it has. And if you use this code to get it from my website, you can get 3/4 of the price off. So please consider it. So that's what I wanted to share today. Thank you.
Thank you. Are there any questions?
I don't know how to start, you know. Just when I started programming, especially in web programming, first I heard is to not invent your own bicycle. And is it this? What exactly have you done? The Angular, which you cleared from all the nested things to show how it works, or you just really made your Angular, which drives a little bit different, and if it drives a little bit different, so I will not understand exactly the core of Angular.
So yeah, I strive to make it exactly equivalent to Angular. So it's purely a learning tool. I don't actually use my own version of Angular. I just use it to learn it. I use Angular itself. The end result of this book is your own version of Angular, which someone might want to use, but it's more the process that you actually learn what Angular itself does. And I think that's the key.
Thank you. More questions?
My question is, have you seen the AngularLite framework, which advertises itself like a smaller version of large Angular?
AngularLite?
Yeah.
I haven't seen that, no. Or at least I don't remember. I've seen some sort of offshoots of Angulars, like someone did a standalone version of the scope change detection and things like that, which was actually based on my book. But I haven't seen that one, no.
It's advertised itself like better solution for the small application
Right.
without unnecessary stuff.
Okay. Yeah, that sounds useful because there's a lot in Angular. Actually, Angular 2 will probably be closer to a sort of Angular Lite in the sense that you can choose like parts of it that you use. Like it's very far from release yet. So you can't use it yet, but it's designed more in the way that if you just want change detection, or you just want components, or you just want some other part of it, you don't have to get it all, which happens with this, the current version of Angular 1. And it sounds like Angular Lite might be doing some of the same things.
Thank you. Now we have a question.
Hello.
Hello.
I have the next question. As I understand, compile function mostly used for DOM transformation that could be made before linking.
Yes.
Yes. And is there any good way to pass some data or configuration into compile function to make this transformation? I will clarify this with example. Let's imagine a data grid component that dynamically builds itself actually from configuration, and this configuration contains some objects that represents each column. And the problem is if how I did it and how it works at the moment, I have two ng repeats, and actually one is embedded into another, and in result I got a very poor performance.
Right.
So I think, okay, maybe I can precompile this template and use only one top level ng repeat and just put precompiled template for the row.
Yeah.
But actually the question, how can I get the data from the scope or from other place if I can get it from the scope on a compilation time?
Yeah, so the scope, it won't be available during compilation time. That's mainly one of the big difference between scope and link. But you can do things, I think, you could always use, you can inject things to the directive, and that's all available for you during compile. So if you can have something available from a service that you have, for example, or even the root scope, which you can always inject. That's all available for you during compilation, but other than that, there's not much except stuff you can find from the DOM that's available in that case, because it's not before the linking happens that you have the scope in there. You might have a chance of actually trying to get to the linking with a higher priority than ng repeat. I'm not sure that if that actually will work for you, but you might be able to do that because of the priorities that you can set on this directive, which affect in which order they are compiled and linked. But
so one option is to use some interaction via some sort service or storage, and another option try to play with priorities. Yeah,
those are the ones that come to mind. What I would probably it sounds like what I would try to do is try to populate some of the DOM contents based on data that you get from some service that you have, and then you would already have it when it's linked. But then, it's hard to. It's kind of going against the design, and in that sense of Angular, which is that your actual application data comes in via the scope, which is kind of what they want you to do. But I think there are options to try different things at least.
Okay, thank you.
Thank you.
Thank you. And we have the last question here, and then we can continue our discussion on the break.
Yes.
On the break. Here is the last question.
Hello, Tero.
Hello.
Hello, Tanya. So, I'm pretty sure you liked the Angular when you started, when you start your work, and after this huge work that you did, you think Angular from inside. Did you change your opinion about this framework?
Maybe a little bit. I'm not sure. I kind of knew that Angular was sort of a mess before I started, because it's kind of visible from, at least for the directives, like you can see right from the API in there, that it's not designed to be like what it is right now. Like if you look at the object that we have, don't want to scroll all the way, but if you have an API like this, it's kind of evident that no one designed that API. Like it's 6 years old now, this API, and it's evident that it has been growing over the years, adding new features to it. So yeah, this process of writing the book has really just reaffirmed the fact that it's a mess. But they're fixing it now for Angular 2. Like if you look at the source code for that, it's like this whole object-oriented thing that has actual design done to it. And it's essentially made for the purpose of actually having all these features. So yeah, I wouldn't say that my opinion of Angular has changed during the course of the book. It's just that I already knew that it isn't perfect.
Yeah, thanks.
Thanks.
Thank you.
Thank you.